Good morning, everyone. I start off by going over the calendar, make sure we're clear on what's coming up.
Good morning. Figures if you have 4A lunch, you send your student 4A lunch.
All right, so yesterday I spent time in the morning just going over 2.4 and 2.5, just the classwork from Monday and Tuesday, or sorry, homework Monday and Tuesday. So I recorded it in case if you guys want to check it out, it's there. Also, I was began collecting 2.1, 2.3 classwork. This is a formative grade, so you turn in late and no penalty. If you still haven't turned in your Unit 1 limits, you can feel free to do that as well. Okay. So today I'm gonna pick out problems from both the test review sheet and the miscellaneous worksheet. Kind of jump back and forth there, and I want to hit on the things that we haven't, the types of problems that we haven't seen yet. I mean, we've seen all the concepts, but just the types of problems. And so we'll do that today. Friday, tomorrow, we're going to start related rates. I'll send you guys a link. I haven't cleaned up the related rates page yet on my website, so let me clean that up, and I'll have the link ready for you guys. I'll send that to you this afternoon. And we'll start related rates, but hopefully, I just want to be able to get through like maybe two or three examples, and then we can spend the rest of the time doing more test review. And then Monday, we'll have another full day of test review. But on this day, I'll probably detail for you exactly what to expect on the test, so no surprises. And then on Tuesday, you'll take your 2.2, 2.5 test. All open response, free response, no multiple choice. I know on the test review there are some multiple choice, but I kind of just picked those problems just for the practice of it, not for the format. So morning help session, 7:15 a.m. through Teams. Okay, so any questions about the calendar this week or next week? Okay, I finished grading most of your quizzes. I put it into the gradebook, but there are still some that I haven't graded yet. I think those who emailed it to me, it just takes me a little bit longer to get. So hopefully I can get those done today. And once I get all the quizzes graded, I will release them back to you so that you can see the comments I made, so you can know what problems you missed, and any ones that you missed, you can understand those mistakes and be prepared for when you see it, if you were to see it on the test. Okay. We also had a faculty meeting yesterday, and one of the new things that was presented to us is that now it's Fulton County policy, at least for this semester, to allow students to recover their quiz or test summative grades up to an 89. So anything below an 89, students should be able to recover up to 89. Now, every teacher, every PLC teacher class may decide what will be required of the student to earn that retake opportunity. Maybe it's attending help session, maybe it's having to do corrections first. So I think for me and Mr. Jones, we have to sit down and kind of walk through and make sure we're on the same page. What are the prerequisites for students to earn that opportunity? But yeah, just to let you know, that's coming up, and it's going to be effective as of this past Monday. And so this upcoming chapter 2 test, you will get that opportunity. If you're not happy with your grade and you want to do a retake, you can you'll be able to earn that opportunity to do a retake up to an 89. And you'll get one chance per summative quiz or test to retake up to a higher grade. Now, if you do worse on that retake, then we'll just keep that first grade. Okay, so you get higher of the 2 grades. So as we figure things out, as we figure more of the details out, we'll let you know. But just to kind of let you know, that is what's coming out, or that is an option, upcoming option for you guys, and it's supposedly for all your classes. It's a Fulton County policy now, but it's only going to be for first semester. We don't know what's going to happen with second semester, so things may change second semester, but at least we know that is the case for first semester. Okay, any questions? Okay. So if you guys can turn over to the miscellaneous worksheet. If you don't have this, just follow along. But these types of, so we haven't quite seen product and quotient rule with a graph involved. So that's why I wanted to go over this. Also, this will be on your test. And also, I think to continue to drive home the idea that derivative is slope, right? So just to kind of get that abstract word of derivative into something that is something that's visual and something that is a tactile, right? Something that you can visualize and put your hands on, right? That slope is just the idea of slope. All right, so let's look at this is I did copy and paste from screenshot from the textbook here. So this is number 81 under 2.3. Let's look at p prime of 1. Okay, but here's our starting point. Our starting point is p of x is defined as f of x times g of x, and that is going to be how we're going to start building our information needed. Okay, so p of x equals f of x times g of x. How are these two related, and what rule do we need to use to find this derivative? Product rule, okay. So f and g are multiplied together. We know we got to go through product rule. And we ignore the 1, okay? We're not dealing with the 1 yet. Let's just get the derivative first. Let's find that p prime, and then we can worry about the 1. Sometimes students, they want to plug in that number a little too soon, and that just throws everything off, okay? We got to work with this. We got to find the derivative first before we can look at that number. So let's find p prime. So product rule, f prime g plus fg prime. Now that we have our derivative established, now we can work into 1. All right, any questions so far? Okay, so we can now look at our graph because our graph is going to help us get these out of notations and into a numeric value. So let me talk about what these mean here. G of 1 and f of 1, these are just asking for the physical location, the y values of the g and f graph at that point. F prime and g prime of 1, what do you think these represent? And how do you think we're going to pull this from the graph?
Is it the slope?
It's the slope of the graph at that point. Yes. Good. Slope of graph at the point. Okay. So let me pinpoint those values and let's see if we can find them. So here is 1. Here's g of 1 here. And here's f of 1. So first up is f prime of 1. So f prime of 1, like you guys said, is the slope of the f graph at 1. So this is part of a line. A line is going to have consistently the same slope all the way through. So what is the slope of this line? 1, because we did rise over 1, right? All you do is pick another point on the graph and then just do rise over 1. In this case, we go up 1 over 1. So 1 over 1 is 1. So that's the slope, that's the steepness of the graph at that point. Good. Any questions there? Okay, moving on to g of 1. G of 1 is just the y value, right? There's no derivatives. We're just looking for the physical y value location. So what's g of 1 going to be? 4, right? Good. The y value. Okay, we're either picking the y value or we're picking the slope. All right. F of 1. Six, right? Okay, now moving back to g here, g prime, what's g prime of 1? Close. Yeah, it's going to be negative 1/2. Okay, so here's what I did was I picked another point on the graph, and I just targeted that point, and I just did rise over 1. In this case, I go down 1 over 2. Remember, we always read the graph from left to right. So this graph is falling, right? So if the graph is falling, we're expecting a negative slope. So negative 1/2. All right, we go through our cleanup step here. 4 times 1 is 4. 6 times negative 1/2 is minus negative 3. 4 minus 3 is 1. All right, so take a moment, look at what we've progressed so far. Any questions, any parts you want me to clarify or go over again? That's good. Okay, so we're either picking the order pair or we're picking the slope. And then for all the lines, if it's a slanted line, just do rise over run. It's either going to be a positive slope or a negative slope. All right, let me pick out some. I do want to talk about slope that are some like exceptions where we don't do rise over run. We kind of just have to kind of know them. So let me just point out a couple of things here. What is the slope at this point? I think
Undefined.
that is an interpretation, right? What else?
Is it undefined?
It's undefined. Yeah. Now, slope 0 would be if the graph kind of has a smooth transition, right? So smooth transition if it's like a top of a hill and if it's a smooth transition, then that's a slope 0. But I guess you can make that argument where if you're standing at that point, you're kind of on the flat surface. But anytime there's a sharp turn, just understand that there's no consistent slope, right? To the left is positive, to the right is negative. There's no smooth transition. So if there's no smooth transition, the slope is going to be undefined. So basically, if you can just visualize yourself running your hand through this graph, if you feel any sharp turn at all, any sharp corner, you know that is a place where slope is undefined. So where else do you see slope being undefined for F or for G?
Would it be G prime 3?
Good. So it may not be as sharp as this, but it's still a sudden shift, right? A sudden change. Okay. Where else do you see undefined? So we're done with this problem. I just wanted to kind of pick out some. Where else do you see undefined slope?
F prime 7.
F at 7.
Good. F prime of 7, and then G prime at 6. Okay. Right. These are all slope undefined, right? You can feel yourself. If you run your hand through it, you're going to feel a little bit of a sharp corner. Some sharper than others, but it's still kind of a corner. Good. So I want you guys to be able to visualize what a slope undefined looks like. What about here? What about at G prime of 5?
Zero.
That's 0. That's definitely a flat surface, right? So that's slope 0. Okay. Let me ask you this. Going to 82. What's the slope here? That's slope 0. Okay. Slope 0. So I just want to make sure that you guys know what slope undefined and slope 0 looks like. Slope 0 is either part of if it's part of a smooth curve and it's either a peak or a valley of a graph, that's slope 0. If it's completely just a flat straight line, that's a slope 0. And then any sudden change in direction, if you can feel a little bit of a sharpness at that point, then that's slope undefined. All right, good. Let's look at 82. And I want to let's look at Q. Let's look at part B. So part B says find Q prime of 7. Before we find Q prime of 7, let's look at how Q is defined. All right, so what's the relationship there? How can we find the derivative if it's in that form? Quotient rule.
Quotient
Good,
rule.
that's right, quotient rule, right? If it's numerator and denominator, we do quotient. If it's numerator, if it's two terms multiplied together with no denominator, then it's going to be product. Good. So we don't touch that 7 yet, right? Let's build our derivative first. And then we can work in the 7. Yeah, let me All right, everywhere you see an X, we can start replacing all the X's with 7s. So I highlight that point. Looks like they intersect, right? All right, so see if you guys can make progress here. You're either picking out the ordered pair of the F and G, or you're picking out the steepness of the F or G graph at those points. Okay, so give that a try and we can see how our answer compares.
The only thing here is the question with that is you have to know that you get a question like this, you got to apply the distance formula 3 times for each. Okay, so that's the practice. But if you can give her any like shortcuts, like when I look at it, rather than see if do I have any that are on the same line, like like here these 2 points, they both have 5 as a y coordinate, so I know it's going to be some any kind of shortcut that it would help her to kind of do the distance one for Kira. I said, I'm not recommending that. But I wanted to show her what to do. Most of the other problems are very short as far as setting up. This is an asset. Yeah. Yeah. And it's not me. You can also create a graphic just to see kind of help her. And she can do that. She can do that on other classes of time. I'm going to do, she's probably, I'm going to email mom and just say, if you want to do paper testing. I think it's, yeah. I'll give you that, and I'll email links to this one. I just highlighted a couple of things here. So I tried to explain, and there's 2, I think there's like 1 through 6, and then we're 1 through 6, so different types. I mean, it's the same type of problem, 2 for each, but instead of 2 back to back, it's 1 through 6, and then it starts again with class 5. And then it's underneath the best of uses. So you keep this copy, and then you've got the file, so you can.
All right, F prime of 7, what'd you guys get for F prime of 7?
4.
2. You guys get 2?
Yeah.
Yeah, good. All right, so I just picked 2 points on the F graph, and I do rise over 1, so up 2 over 1. That's a slope of 2. Good. How about G prime of 7? -1, right? Good. Good. -1. It's not as steep, but if I pick another point and I go down 1 over 1, I get -1, right? Good. All right, so see how your answer compares. See if you got 3/4. Both the F and G share the same Y value, so you have repeated 4s here, down here too. All right. Any questions? Is there any parts you want me to go over again with you? If you saw this on the test, will you be comfortable enough to work through it without any issues? Good. Now I started with product and quotient rule because these are more straightforward. Like once you plug in the value, you're just picking out slope or order pair. Chain rule is a little bit more involved. I mean, we have to kind of take it step by step a bit more. So I wanted to make sure that we're good with understanding whether picking out your order pair or slope. And then let's look at chain rule, because chain rule is going to be a little more involved, but you know, we're kind of just, it's like one step after this, after we've mastered these types of problems. Okay, let's go to the next page. And still on this miscellaneous worksheet here, but let's go to number, next page is 99. Whoops, sorry, fourth period, sorry. Label my sheets here. Number 99 here. Okay, so now we're dealing with h of x, but look at how h is defined. So what rule do we need to involve to find its derivative? What does this look like to you?
Chain rule.
This is going to be chain rule. Do you see how this g is inside the f? So here's something that I think, yeah, so let me name that here. This is chain rule. So chain rule says we got to take the outside's derivative and then work in the inside's derivative. But we got to do it in a certain way, right? There's a certain way that we have to follow a procedure with chain rule. I do want to point something out here, as this is what I've seen students to do. Seems to have, sometimes it's easy to get confused between product rule and chain rule, but look at this, the subtle difference here. Chain rule only has one x in it, because it's a function within the function. Product rule has two x's in it. It's f of x times g of x, so there's two different instances of x's. So I don't want us to get confused and think that we're doing product rule when we're actually doing chain rule, and that's something that that may happen. So I want to make sure that we're clear. We're able to see an expression and be able to know which category it falls under. Okay, so chain rule. Chain rule says find the outside's derivative, then multiply by the inside's derivative. So if we look, f is on the outside, right? So we know f represents the outside function. So we're going to take its derivative. And the way that we take its derivative in this notation is we say f prime, but we leave the inside intact. We're not ready for the inside yet. We're just taking care of the outside. So first portion of chain rule is f prime of g of x. That's the outside portion. This is the outside portion, or at least the notation for outside derivative. Multiply by the inside's derivative, and what represents the inside's derivative? Times what?
G prime.
Times
G prime of x.
Good, g prime of x. This is my inside derivative. All right, any questions so far? Okay, so now we can work in the 1. Okay, now we can work in the 1. So if you look at this, this looks a little bit more complex than product rule, right? because there's kind of like this messiness that we didn't have to deal with product rule. But maybe we can take it one step at a time, right? Maybe we don't have to do everything all at once. So what seems manageable? What do you think we can find easily to begin with?
G of 1.
So we can find, there's just two things, right? Two things that I see are easy to find is G prime of 1 and G of 1. I think what we don't want to do is we don't want to look at F prime and figure out, okay, what is this F prime? We don't know yet, right? This is too big of a puzzle right now. But let's handle the parts that we can figure out and then see where that leads us. So we can find G of 1. I'll save that G prime of 1 for later. Right now, I just want to just focus on the part that feels complex, and we can kind of break it down step by step here. So what's G of 1? Right, 4, right? Just the order pair. This is not asking for the slope. There's no prime. The prime is with the F, but not with the G, right? This is purely just the Y value. So I'm going to rewrite the entire problem, but I'm just going to make that simple substitution. G of 1 is equal to 4. And see if that will help us determine our next step. So I made a simple substitution, but I think it becomes easier to determine our next step, right? So now we have a number here. Now this becomes easier to interpret, right? Now all we need is F prime of 4 and G prime of 1, the slope of the F graph at 4, the slope of the G graph at 1, and then multiply the results of those two. So let me highlight F prime. Let me highlight 4 on the F graph. Okay, so what's F prime of 4? -1, because that's the slope, right?
-1.
Good, -1. Down 1 over 1. Okay, G prime of 1. What'd you guys get?
Negative half.
Negative.
Yeah, -1/2. Good. Rise over run. They're both negative slopes. One is steeper than the other. But we have what we need to determine our answer. -1 times 1/2. Sorry, -1 times -1/2 is just 1/2. All right, take a moment, look at what we've accomplished. Any questions about any step along the way? It's a little bit more involved, right, than product and quotient. We got to do a little bit of kind of piecing things together. We can't just find everything in just in one go. Okay, why don't we try another one of these just to kind of see how we feel doing one on our own. So for B, let's find S prime of 5, but look at how S is defined, and we may need to create something a little different because of the order there. All right, so hint is chain rule again. Use A as a model to help you with your steps. Let's see how far you can get you can get through this on your own, then you should feel confident that you're ready to handle this type of problem on the test. All right, let's see what we've gathered so far. How would you define the derivative for s prime of x? Sorry, you're breaking up. Say it again.
G prime f
Good.
of x times f prime x.
Right. So notice how it's not quite the same as this, right? Because we have different functions representing outside and inside. Here, for a, f is the outside, so that's why it comes first. G is the inside, so that's why it comes second. But here, the order is flipped. So we got to follow whatever the problem gives us, right? We can't just copy the same rule for every time we see chain rule. We got to adapt to the variable in the problem. Good. So outside's derivative, G prime, first, followed by f prime. Okay. Replace every x with 5. We're now ready to put in our numeric value. So this is a complex expression, but let's deal with the easy part. Let's just find that one replacement, and that'll make things a lot easier. So what's f of 5?
6.
Yeah, f of 5 is 6, right? Good. So one replacement I'm going to make, and it's going to make things a lot easier to interpret. So after that one substitution, now I'm just looking at the result of two slopes at two different graphs across 2 points. So what's g prime of 6?
Undefined.
Good, undefined, right? We talked about how if you can feel any type of sharpness, any type of corner of a graph, that's undefined. So basically, if undefined shows up anywhere within your calculation, it's going to turn that answer to just be automatically undefined. but just for practice case here, f prime of 5 would just be -1. Okay, we don't need this, but just to practice. Ultimately, though, s prime of 5 is just undefined. So anytime you see undefined, that's going to be our, that's going to carry down all the way to our answer. Or it does not exist. I mean, you can use anything that you want to say. All right, any questions? Are we comfortable with this? We see this on the test. Are we good? Okay, good. All right, let's go to our test review. I want to pick out another problem for us to look at. This is another test question I want to type that I want to go over. So if you can flip over to your test review handouts or printout. Let's go to number 5. We haven't quite seen something like this, so I want to kind of go over the details of this problem. This is like a common type of a problem that you may see on an AP exam in the multiple choice section. They like to see if students understand this concept, and this is a common format that I see on the regular basis on AP exams. Okay, let's break this down piece by piece here. We have a piecewise function. You have two graphs. We don't know what A and B are. Cubic and a quadratic, and then we want them to connect at 3, but the way they're connecting is very specific. That's what that word is telling us, differentiable. Let me define that again. I talked about it when we went over 2.1, but just to review. Differentiable means smooth curve. So that means no sharp turns, no slope undefined, no vertical asymptote, no holes. So more specifically, slope exists everywhere. That means you can have a slope 1 or 2 or 0, but you can't have slope undefined. There's no sharp turns. So this may seem obvious, but this is something to verbalize as well. If the slope exists everywhere, that also means that the graph is going to be continuous everywhere, right? There's not going to be any vertical asymptote. There's no holes. And that seems very obvious, but it's nice to verbalize it because it's going to help us with our next step. So if something is smooth curve everywhere, that assumes that it must be continuous everywhere as well, right? We've got to have continuity in order to even have a chance of achieving smooth properties. All right, so this may not be what the graph looks like, but I want to kind of have a visual to help us with this. So we have two graphs, right? And we want the graph to connect in a way where not only are they connected, but it's going to be a smooth transition, right? Those endpoints are going to connect in a way where you're not going to see any sharp turns. It's going to be a smooth transition. So maybe a graph like this, ax cubed, maybe something that has this. And then x squared plus b is going to pick up from that point, and it's going to be a smooth transition So that's ultimately what we want to happen. We want to figure out A and B so that we get that connection and we get that smooth transition. So this is what we can do. If it's continuous everywhere, that means these two graphs, they must share the same y value. So if they share the same y value, that means we can set these two equations equal to each other. So if continuous, then that means we can set the equations equal, because that indicates that they must share the same y value. And they share the same y value at x equals 3, right? Because that's the point, that's the center of our attention there, is at x equals 3. So I'm going to go ahead and just set them equal to each other. And we can come back to that later. Okay. At least we have an equation to work with. But we also know that it's differentiable . And we know that the slope is going to exist everywhere. That means they must share the same slope. So what can we do to indicate that two graphs share the same slope? What else can we set equal to each other? Any ideas?
Their derivative?
They're derivatives, right? Because derivative is slope related. So if I can set the two slope related equations equal to each other, that means we're forcing a situation where they're going to have to share the same slope. Good. So we set the derivatives equal. And again, center of attention is at 3. All right, so this takes a little bit of effort here. We're going to have to find the derivative of both of these separately and then set them equal to each other. Remember, a and b are just numbers. They're just constants. So what's the derivative of ax cubed? Yeah, 3ax squared. If you're having trouble kind of seeing that, imagine the a as a 2. And if I ask you, what's the derivative of 2x cubed, you would say 6x squared, because you would bring down that 3 and you would multiply by the 2. Same idea here, it's just that we got to hold on to that a little longer, so it's going to be 3ax squared. Sometimes students are asking, well, I thought a was a constant, so shouldn't it go to 0? But anytime you have a constant that is attached to the variable, it kind of just sticks. It doesn't go away. But if a constant is sitting there by itself, then it goes to 0. Okay. All right, so there's my derivative for my first term. What's the derivative for my second term?
X.
Say it again.
2x.
Just, yeah, 2x. What happens to
2x.
the b?
Becomes 0.
Becomes 0. Good. Right. So I want to make sure that we're distinguishing, right? Here we keep the a, but here we lose the b. All right. So the hard part is done. Now the rest is just algebra. We're going to replace every x with 3 and then see what we can do to solve for a and b using the two equations to kind of help each other out. So, but yeah, this is the most important step here. Are we clear here? All right, I'm going to replace every x with 3 and then see where that leaves me. Three cubed is 27. Now here, I'm kind of stuck at a stopping point, right? I can't solve for A and B separately. I don't have enough information. So we'll stop there for a moment and let's go to the other one and see maybe we can gather some information that could be helpful here. So I'll replace every x with 3. Well, the nice thing here is that B just dropped out, so we should be able to solve for A. So 3 times 9, 27. Okay, divide both sides by 27, and we can get that A to clear. Okay, so I found A. So we can use this now to help us figure out B on this side, right? (27) divided by 9 is 3. 3 times 2 is 6. Good. We can solve for B here. Subtract 9 from both sides. So there we go. We have our A and we have our B value. All right, any questions? All right, one final thing that I want to do is let's look at number 1 at the top of this page. So number 1 says, find the average rate of change. So another word for average rate of change is simply slope. So slope is just change in y over change in x. So there's no derivative involved, but it is slope related, right? Rate of change is slope related, but we're not having to use the derivative because we're not asking for the rate of change at a point. We're looking at a rate of change over a course of 2 points, so there's no need for calculus. We just rely on order pairs and slope. So 3 minus 3 over 3 minus 1. Any questions there? Okay, one last one. If you look at number 2 here, the wording is almost the same, but then there's this word that's instantaneous. So now it's asking, what is the exact steepness at just that specific point? So now we got to rely on the derivative because with slope, we will not be able to do it because we only have one point to deal with. So we first have to, involve derivatives here. So first we need to find f prime, which is what? Just power rule, right? 4 minus 2x. And we just want to find the steepness at those endpoints separately. And we plug into f prime, right? We don't plug into f of x anymore. We're dealing with f prime now. So the exact steepness of this graph has a steepness of 2. And then that 3 it happens to be negative 2. All right, so just to give you a visual here, here's what the graph looks like. 4x minus x squared looks something like this. And what we gathered was at 1, there's an exact steepness of 2 here. And then at 3, there's an exact steepness of negative 2. And the reason why we're getting 0 was because the slope between these two endpoints is a horizontal line, so that's why it's 0. So the average rate of change is the slope between those endpoints. Instantaneous rate of change is it's only one point involved, so we have to involve derivative because derivative is the only one that can give us steepness at a point. All right, so off of this test review, you can turn to the back. This is your homework, just number 6. Particle motion. You saw something similar to this on your quiz. And so that this can be kind of fresh in our minds. And then we'll pick up tomorrow with related rates. We'll do a little bit more review. Okay, test on Tuesday. I'll send you guys a link with related rates worksheet. All right, thanks everyone. Hope you guys have a great day.
Thank you, Mr. Yang.
Thank you.
Have a nice day, Mr. Yang.
Thank you, Mr.
Take care,
Yang.
guys.
Thanks, Mr. Yang.
Bye.